Welcome back to the Maker Bob, and today we're making a custom slitting tool that I need for a project in the future. This was made out of 4140 and will be able to cut soft plastics like HDPE and soft timbers like pine. We're not working from an exact plan, but what we have is this bar of 4140, which we're going to take a skim cut, and that's going to be our outer diameter basically of the cutter. We might take it down to a nominal dimension. I think we ended up making it 32 millimeters. The major requirement of this tool is to be able to cut a 3.5 millimeter wide slot that can be 12 millimeters deep into the material. I decided to make the shank 8 millimeters to fit inside an ER32 collet, and now we'll just start toning all the way down to that 8 millimeters. I have to say I'm very happy with this new lathe. It's got a power feed, both cross-slide feed and carriage feed. It makes toning a part like this so much easier. I just dial in the depth of cut, turn on the feed, and just let it do its magic. Here I'm taking a little measurement to see how close we are to the final diameter. I then dial in the last bit of the cut, and then we'll soon have a finished shank. Here I've made it just slightly undersized, but that's okay. We'll keep going with the part. I'm just cutting a bit of relief on the shoulder here so that the tool has a little bit more clearance. And then on the back side of this disc, I'm cutting a relief so that the back end of it's not rubbing on the material all the time when it's cutting the slot. A quick polish with a bit of sandpaper and a deburr of the end with the file. And we're off to the bandsaw to cut this off. Now we're using the bandsaw because I don't have a parting tool for this lathe at the moment. All my parting tools from my small benchtop lathe do not fit. I think that's a project for the future, adapting those parting tool blades to this larger lathe. Alright, now that that's all cut off, we'll back over to the lathe and we're applying some nail polish here to use as some marking fluid. And then we'll mark out the 3.5 millimeter disc that we want. And once that's done, we'll start toning away, create a little relief, and then we'll move over to the milling machine to finish off the cutter. With that all complete, we now have the slitting saw blank. Now over to the milling machine, we've got it in a hex block, collet block, and here we'll just cut in the flutes. For the first cut, I thought we could use the coolant from the milling machine to lubricate the part and keep it all nice and cold while cutting. But in the end, it was just creating more mess than it was sort of helping, so I just moved to spray on coolant for the following cuts. The idea here is that we will just use the x-axis of the milling machine to cut directly through the disc, and that's going to create a sharp edge. Then we'll rotate it one position on this hex box and move across to the next flute until we come around a full 360, and we should have a slitting saw. here we have the first tooth cut, and it's looking quite good, so we'll just move on and cut the rest of them. And here we have our final product, a 3.5mm slitting saw. Now this is only cut out of 4140 steel, so it's not the hardest thing in the world. You will not be able to cut aluminium, definitely not steel with it. But as you'll be able to see with HDPE, it cuts like butter, so fit for purpose, I think, and job well done. Well, that job's complete. I would like to thank you for watching, and if you have any ideas for future projects, please let me know, and I'll see you on the next one.